Good morning, dear students. This is Dear Hanumantu, Assistant Professor, Department of Engineering, University College of Engineering, Aditya University, Rajmahendra. Last case, last class, we discussed about introduction about fiber optics and laser instrumentation. What is fiber and what is optics and laser and the importance of instrumentation for the fiber in industries, right? So here today class, we are going to start the chapter 1 and we see the basic information regarding fiber, right? So in the last class we discussed about what is a fiber. What is a fiber? So fiber is nothing but combination of core and clad. So you all know that core is different material and cladding is also different material. So how do you combine these two? So generally this core is made with some glass and cladding is made with some other material like glass and other composition. So what happens for any core the refractive index is different and for cladding the refractive index is different. That means the two devices, I mean the elements having a two refractive index placed at one place, so that is nothing but a fiber. So combination of core and cladding, it is nothing but a fiber, right? So what is the purpose of this fiber? Fiber is a waveguide. It guides the light wave, and otherwise fiber is a medium. It acts it acts as a medium in between the two devices like transmitter and receiver. So the main importance of this transmitter is simply it converts the inputs into light signals with the help of light sources, because as I told last class, the transmitter having some LED and laser. So these two comes under light sources. They will convert into light. Whatever the input we are going to give, that will convert into light. That light is simply coupled. That light is simply coupled, joined to the fiber. So this fiber accepts that light and allows for transmission. Remember once again, it is a very important point. The fiber accepts the light, allows for transmission. Allows for transmission. So here there is you have to know one important point. How this light is going to propagate through the fiber. Fiber means, remember, fiber means is a combination of core and cladding. And we have one more point, fiber cable, combination of core, cladding and jacket, outer jacket, front material. So that combines the three combines the laser, combines the cable. But fiber means only core and cladding. If the transmitter gives the light signal, that is entered into the fiber cable and it is going to propagate throughout. So how this light is, where this light is going to propagate? The answer is the light should be within the core. Remember once again I am speaking, the light should be within the core. Within the core. If the light is within, out of the core, say suppose some light is within the core and some light is entered into the cladding, what happens? If light is within the core, it is fine. It is good. If light is entered into the cladding, that is called loss. That is called loss. It is also called transmission loss. Transmission loss. So the fiber is a medium. Fiber is a waveguide that allows the light for transmission throughout. At the end of the fiber, light is emitted. Light is emitted. So that whatever the light is emitted, that is for that will fall on the detector. Where is your detector? Detector is in the receiver side. So when the light falls on detector, that detector like pin diode, photodiode, avalanche photodiode, like this. These are detectors. When the light falls on this, they will convert the light photons into the original signal, light signal, the electrical signal. Because at the input side we are giving electrical signals, so at the end also we are receiving same electrical signal. So this is what the basic the thing happening in the fiber optics, right? So today our concept is our please share the second slide, ma. See, what is optical fiber? An optical fiber is a heavy cylindrical fiber of glass or any transparent dielectric medium. It may be, remember, this fiber is nothing but core on cladding. How this is core and cladding is made? It may be glass or any transparent dielectric medium, maybe like sand, other materials you can use. Fiber this fiber generally useful for communication purpose. So there the easy people may apply for communication, but instead people like you can apply for industrial purpose. So how this fiber may be useful for industries, as we discussed last class, this may be useful for general applications like voltage measurement, current measurements, temperature measurements, distance measurements, acceleration measurements like this. Sometimes you can use this fiber for medicine sites, medical sites like endoscopy, like endoscopy. So, so next slide. See the structure of the optical fiber. How this structure is provided. See this one, the blue color one is center one is core, and other than this blue is nothing but this one is nothing but cladding. After this is a covering. This one is covering means a strength material or jacket. You can call jacket. So it is called core, cladding, and it is jacket, outer jacket. Next. Okay. See the characteristics. Characteristics means um, uh, see how can we understand this fiber for some other purpose. See the bandwidth. Bandwidth of this fiber is enormous. Enormous bandwidth. Because if you see the coaxial cable, in the early days we are using a coaxial cable, general cables. So it is made with some electrical wires. Electrical wires. Resistor, capacitor like this. So this coaxial cable is made with some electrical wires. Through that the communication is done in the early days. But nowadays the communication is completely with the fiber cable. So what the advantage of this fiber cable? Fiber means see the wider bandwidth. Optical carrier frequency in the range of see 10 power 13 to 10 power 15 hertz. See, it is enormous bandwidth. Bandwidth is very high. And one more point is low transmission loss. Low transmission loss. Suppose if communication is done with coaxial cable, you can expect maximum loss because if I am speaking, hello, how are you, with the coaxial cable, at the end, it may be noisy signal. It may be noisy signal. Of course, you may receive hello signal, but it is high noisy one. Because why it is high noisy? Because the coaxial cable doesn't give low losses. But if come across this fiber cable, the fiber having transmission loss of 0.002 decibels per kilometer. Per kilometer, you can expect 0.002 decibels. So the loss is measured in terms of decibels here. Per kilometer, we are measuring because the fiber length is 1 kilometer. If you take a fiber cable from one end to other end, it is maximum of 1 kilometer. But how many fiber cables are there for in the communication? We don't know. From here to Hyderabad or from here to Delhi, how many cables are there? 1,000 cables. Maybe in terms of 1,000, 2,000 cables. Each cable having 1 kilometer. You understand how many kilometers cables we need for from here to Hyderabad. For example, 500 cables. Each cable may give 0.002 decibels loss. Isn't it? Into 500. How much loss? Is very less. That is acceptable loss. That's what my point. So if you use communication with the coaxial cable, the loss is high. But for the fiber, loss is very less. That is the advantage with the optical cable. And one more is dielectric waveguide. See, the fiber is made with silica, plastic or glasses. So because of these material compositions, it acts as a good waveguide. Good waveguide. Why it is called good waveguide? Good waveguide means, imagine once again, how do you imagine a communication link, a transmitter and a receiver, in between a medium like fiber. Transmitter will give some light. That light is entered into the fiber cable, into the core. Right. But when the light is entered into the core, that the light should be within the core. How it is possible for the fiber to allow the light within the core? Because of dielectric characteristics. I will tell you the basic principle in the next slide. The reason behind is, when we are manufacturing a core and cladding, core should be some other material like high denser medium, and cladding should be less denser medium, lesser other compositions. Core compositions are different from cladding compositions. So what happens? There is a difference in refractive index. Because of difference in refractive index, the light should be within the core only. That's what dielectric waveguide characteristics. Right? Signal security. Next one is signal security. The signal through the fiber does not radiate. Sometimes we cannot say that 100% it is correct. Signal security is not 100%, but there is a comparison. If we compare with the coaxial cable, other communications, in the fiber communication, the signal is highly secure. Of course, there will be some expected loss. Expected loss, you can expect. As you know, that 0.002 decibels per kilometer is very less and acceptable loss. So signal security means, so when the light is propagating through the fiber that does not radiate. Radiate means the light should be within the core, what we are expecting, but sometimes light may be out of the core sometimes. Some of the light may be out of the core, maybe in the cladding, sometimes after the cladding, means in the jacket, or maybe out of the jacket, that means into atmosphere. It is not permittable, but there will be some chance. It is very negligible, so it is called signal security. Next characteristic is small size and weight. You know what is that? Fiber is nothing but the thickness of the fiber is like a less than human height. So that's what these are the characteristics of this fiber. Next, working principle. Working principle means, see how this fiber will be useful in the communication purpose. Means this fiber may be useful in the communication because of the basic principle, total internal reflection. This is very important. Listen carefully. Total internal reflection. What is total internal reflection? See, fiber is nothing but combination of core and cladding, right? How this fiber is, the core is going to make, core is going to make some material, right? And cladding is also made with some other material. Remember, core having some index, cladding also having some index. Remember, the two index is not same. The two indexes are not same. What is index generally? Tell me. What is index? What is that refractive index? Refractive index means this can be easily understood by go for next slide. Go for next slide. Yeah. See, the total internal reflection in optical fiber can easily be understood with see the graphs. See, there is N1 and N2. N1 and N2. What is N1? N1 means one refractive index. N2 means other refractive index. For example, here we can apply for core having some refractive index, say N1. Cladding have some refractive index, say N2. So here we are taking two combinations, core and cladding at the same time. There is a boundary. It is called boundary in between. This is called shaded one is core. The white color is cladding. Say we are taking the uh, two indexes with some boundary. Fine. When the light enters from here, we are taking example is water and air. You can imagine here core and cladding, no problem. So when the light enters into the core, because because core is made with high high refractive index, high refractive index. I will tell you what the meaning of refractive index. Refractive index means the velocity of air, velocity of light in air divided by is a ratio of air velocity of light in air divided by velocity of light in the matter. In the matter means in the core or in the clad. That is the meaning of this. Velocity of light in air divided by velocity of light in matter. Matter means core or clad. So this is the definition of refractive index. See, for example, for core, what is the refractive index? N1. N1. N1 can be calculated like this. N1 equals to refractive index of the light, velocity of the light in air divided by velocity of light in core. That's the meaning of N1. How much N1? N1 is very, very high generally. Next, for N2, how do you calculate N2? N2 equals to velocity of light in air divided by velocity of light in cladding. What is the value of N2? N2 should be less than N1. N2 should be less than N1. So how do you say N2 should be less than N1? We have to take the materials for fabricating core and cladding such that if you fabricate N1 core, that should be high. To fabricate cladding, that should be low. Accordingly, you have a design like this. You have to fabricate N1 should be greater than N2. Other parallel. That is the meaning of combination fiber. Fiber means combination of core and cladding. N1 should be greater than N2. So if you fabricate N1 should be greater than N2, then this is what happening. What is happening? When the light enters into the core boundary, see, this is the first case. Light is reflected sometimes. See, this is the light is reflected. Some light is refracted. Some light is refracted. Reflection means within the same area. Refracted means out of the other area. If you increase the angle θ1, the refracted ray that is bended towards parallel to boundary. If you increase this angle, whatever the light ray refracted, no refraction, only reflection. So what is the meaning of Total internal reflection. Total internal reflection means when the light will fall on the core, the same light within the core only. No refracted ray in the cladding. No refracted ray in the cladding. So whatever the light entered into the core, the same light within the core. Within the core. This is the meaning of this. No light should be entered into the cladding section. In other words, the refraction should be zero. Refraction should be zero. Only reflection. If light enters in the core, the same light should be within the core. Within the core. Go for next slide. Go for next slide. Yeah, this is happening. This is happening. See, we are showing the two types of rays here. One is red color ray and one more is blue color one. This total shade, the shade is core only. It's completely shade. It's completely shaded one is core. I am showing only core, not cladding. Not cladding. Out of this core there is a cladding, and out of this again we have a jacket. Leave it. But here, this one is only core. See, when the light enters, the blue color light, that should be within the core. That is within the core. Otherwise, when the light enters, a red one, that should be within the core. Within the core. Light signal 1, light signal 2. Clear? So, what is total internal reflection? Total internal reflection means the total light should be within the core. That's the meaning of this. Total light should be within the core. Next one. Okay, it is about classification of optical fibers. Optical fibers maybe we can classify like this. On the basis of the number of modes propagating the optical fiber are classified into two categories. Actually, before this single mode and multi mode, we have one more. Go for next slide. It is better to understand. Yes. Okay. On the basis of the refractive index, this is important. This is important. So basically, this optical fiber can be classified as step index fiber. Dear students, understood the meaning of total internal reflection because your whole subject depends upon the basic principle like total internal reflection. Understand? So, what is the meaning of total internal reflection? The total light, whatever the light enters into the core, that should be within the core, that should be propagated. No light should be in the core, in the cladding, and no light should be out of the cladding or into the atmosphere. That is called loss. That is called loss. See here we have, okay, fine. That type of core and cladding combination fibers we can design, we can manufacture, right? Here we have two types of optical fibers. One is step index, and one more is graded index. Graded index. Go for the previous fiber, previous slide, previous one. Yes. So here we have single mode fiber and multi mode fiber. So what is called single mode fiber and what is multi-mode fiber, SMF, MMF? What is this meaning? See the first diagram. This is the first diagram. It's called single mode fiber. It is a fiber. It is a fiber, single mode fiber. What is called? This is called light source. This light source available with the transmitter side, and this is a medium. At the right side, you can see that receiver. I am not showing any receiver here. So this is the transmitter side. This is the receiver side. In between a medium. It is called a medium. So when the light falls, this transmitter having a light source like LED and laser. See, you can choose any light source like LED or laser. So what happens in the transmitter side? Whatever the electrical signal we are going to apply, that is simply converted into light signal with the help of LED or laser. So that light should be coupled to the fiber like this. When the light falls onto the fiber, there is a coupler. It's called optocouplers. Optocouplers. So because of this optocouplers, the light should be coupled to the fiber. Coupled to the fiber. Then the light enters to the core. When the light enters into the core, that is going to propagate like this, the direction like this. The arrow marks I am showing, like this the light is going to be propagated. Clear? So, when the light propagates, as we show that the light should be in the zigzag manner. Light should be propagated in the zigzag manner. Why it is called zigzag manner? As we discussed just now, total internal reflection. Total internal reflection means when the light enters in the core, the light should be within the core. Within the core means what is the fraction of the light? When the light falls within the core at one point, that is reflected back. Next, again reflected back like this. Totally the light is reflected. So in the single mode fiber, what is called single mode means the light is going to choose only one path for propagating throughout the fiber. That is the meaning of single mode fiber. There are different fibers available we can design as per our requirement. Single mode fiber, within a single mode fiber, the light going to choose one path for propagation purpose. Propagation. So that is called type of single mode fiber. Generally, the single mode fiber very useful for some applications, and the source we want to place is laser, not the LED. For single mode fiber, we have to choose the source is not the LED but laser. Because you see that what is the advantage with the laser than this LED sources, because laser having more directional outlight sources, more directional than this light LED light source, light signals. Right. Next one is multi-mode fiber. Multi-mode. The word multi-mode refers to number of modes, number of paths, number of directions, number of ways the light is going to choose within the fiber in order to propagate. That's the meaning of multi-mode fiber. We have to design a multi-mode fiber, right, such that when the light enters into the fiber, fiber means what? Core. Remember, the fiber means core and cladding. The, sorry, the light enters into the core. That light may choose different directions, different paths, different ways, different modes to propagate within the fiber, within the core. That is called multi-mode, number of modes. Remember, so see that the light, see, these one light, these another direction, this one mode, this other mode, this another mode. They are showing three modes here. Number of modes the light is going to be choose. So the light signals may be, the directions may be more number. That's called multi-mode fiber. Multi-mode fiber. So in this multi-mode fiber, there are some disadvantages. We will see that what are the transmission characteristics. On the heading we see what is happening in the case of single mode fiber and multi-mode fiber. So when compared to single mode, in the multi-mode, we are expecting some delays, group delay. That is called group delay. Delay losses that is occurring in the multi-mode compared to single mode fiber. Okay. Now I am going to stop because I have to go for other duty. Right. Now I am going to stop. Tomorrow morning sharply, we see that other transmission characteristics in the optical fiber. Right. So don't miss these online classes, dear students. If not possible, you can, okay, the same class will be uploaded in the YouTube. You can watch there also, right? Okay. If you have any doubt, you can, don't hesitate. Feel free to ask me. You can call me or mail me. Okay. This is about the basics regarding fiber and types of optical fiber and the basic principle of total reflection. Okay, ma?